Welcome to lesson number 5. We're going to be looking at converting from general to standard form by completing the square. Now here we have some examples of perfect squares. Now if we wanted to expand our perfect squares, remember x plus 4 squared and x minus 5 squared are not going to turn out to be x squared plus 16 or x squared plus 25. Okay, that is not what these work out to be. Instead, x plus 4 squared needs to be expanded to x plus 4 times x plus 4. That's what this exponent tells us. It tells us repeated multiplication, in which case we need to FOIL this. We would have x times x giving us x squared, x times 4 giving us 4x, and then 4 times x giving us another 4x, and 4 times 4 giving us 16. So what this is going to work out to is x squared plus 8x plus 16. The difference between this and this is that in purple we have a middle term, and in this one here it's just a binomial, but we want to end up with a trinomial. And remember, there's a shortcut for solving these. If we have x plus 7 squared, rather than foiling it each time, we can remember that the first term is squared and the last term is also squared. But the middle term is going to be a combination of the 7's and the x's. So a 7 and a 7 is 14 and a 14x. Likewise here, this would be x squared, and then my last term, -5 and -5, would be positive 25. My middle term, however, is 5 and 5 is 10x. Now, if we were to factor the following into perfect squares, it is simply just a case of square rooting the first and last terms. So this would become x plus 3 squared. Here we would have x plus 6 squared. If we have a negative in front of our middle term, this would be x minus 8 squared, and x minus 2 squared. Now, in order to make these perfect squares, we want to add the appropriate missing term. So here we know that in order to make this perfect square, we had to add 2 x's together. And if we're just adding 2 x's together, then that's 1x each. So this is going to be 1. This would result in x plus 1 squared. Here we would have to add half of 18 is 9, and 9 squared would be 81. And so if we were to write this as a perfect square, this is going to be x plus 9 squared. For something like this, let's look at this one here. Half of 3 would be 1.5, or 3 halves. And if we were to square 3 halves, we'd end up with 9/4. So this would become x minus 3 halves squared. Now let's look at class example number 1, where we're going to follow these steps in order to express y equals x squared plus 10x plus 16 in completed square form. And then we're going to use a graphing calculator to verify that our equations are represented by identical graphs. Okay, so x squared plus 10x plus 16. We're going to start with rewriting our equation. Y is equal to x squared plus 10x plus 16. Now, before we start, let's read what we got to do in our first step. We want to take half of the numerical coefficient of the x term and square it. Okay, so half of my numerical x term is 10. That's my numerical coefficient of my x term, and we want to take half of that. So x squared plus 10x, and we're going to leave some space here. And we're going to add our 16 over here, because in the middle, where my multiple ellipses have ended up, we are going to be taking half of this coefficient and then squaring it. So what we're going to be left with is y is equal to x squared plus 10x. Half of 10 is 5. If I square 5, I need to add 25. And then I still have this positive 16 over here. Now, we want to add and subtract the squared number in step 1. So I added the squared number, but I need to also subtract the square number. So I added 25 and I subtracted 25. We need to do this because this keeps the value of the function the same. The last step is to form a perfect square, but we want to write it in factored form, and then we want to simplify. So I'm just going to put brackets around my perfect square. So here's my perfect square, x squared plus 10x plus 25. However, we want to write this in factored form. So y is equal to x plus 5 squared. And then we want to simplify what's outside of my brackets. So negative 25 plus 16 would leave us with minus 9. So let's take a look at what this graph actually looks like. Make sure that they are identical graphs. So here I have x squared plus 10x plus 16. And I have x plus 5 squared minus 9. So there's my first graph, and we'll wait until this stops loading here. And it drew my other graph over top, which means that they are, in fact, identical. Now a function f is defined by f of x is equal to x squared minus 9x minus 20. We want to determine the minimum value of f by writing the function in standard form. So again, we need to repeat step 1, 2, and 3 here. And we'll begin by writing out our function. F of x is equal to x squared minus 9x minus 20. We need to take half of our middle term, which is negative 9. So 1/2 times negative 9 is equal to negative 9 over 2. So my next step here, f of x is equal to x squared minus 9x. But when I place it in step 2, remember I need to square the number. So if I square negative 9/2, this is going to be adding 81 over 4, which I also subtract at the same time. And that's what I'll be left with. So f of x is equal to, if I write this in perfect square, that's factored, minus 9 over 2 squared minus, the quick way dealing with these types of fractions is to go negative 81 divided by 4, and then we want to subtract 20 from that and convert back to a fraction, negative 161 over 4. So we know that this is going to be kind of a standard parabola, but our minimum value is going to be way down at negative 161 over 4, which is actually around 40 1/4. So our min is equal to negative 161 over 4. So here I have somewhat of a different example. Now we're writing ax squared plus bx plus c in standard form. Before, we didn't have that coefficient in front of my degree, and so the process is going to be a little bit different. And so we're going to follow step 1, 2, 3, then we go down to step 4 and step 5. So I want to convert this 3x squared minus 18x plus 20 to standard form by completing the square. So f of x is equal to 3x squared minus 18x plus 20. Now step 1, I want to use the coefficient of x squared as a common factor for the x squared term and the x term only. So what I'm going to do, using that as a common factor, I'm going to factor 3 out of this part of my quadratic equation, or my quadratic function. So factoring that 3 out, I'm going to be left with x squared minus 6x plus 20. Then I need to take half of the numerical coefficient of the x term and square it. So now I got to do what I did before, but remember, this is all taking place only in the brackets. So half of my x term is going to be negative 3 squared. And so I need to add and subtract that number. So plus negative 3 squared, which is 9, and subtract negative 3 squared, which is 9. Now, step 4, I want to multiply the term which has been subtracted in step 3 by the coefficient of x squared and combine with the constant term. So only this term here am I multiplying by the coefficient. So I'm taking this 3 and I'm multiplying the negative 9. So this is going to become 3 times. Oh, and another thing I need to do is I want to place this part in factored form. So this part in factored form would be x minus 3 squared, and then this 9 times this coefficient is going to be negative 27 plus 20. And then I simplify. So f of x is equal to 3x minus 3 squared minus 7. Now, our minimum value, so determine whether the graph of the function has a maximum or minimum value and state the value. So since this is opening upwards, it has a minimum value and it has a minimum value equal to negative 7.